Let us start this video from where we left in the last class. So a graph is nothing but it's a set of two sets. So there's a first set called the vertex set and there's a second set called the edge set. So graph is nothing but some collection of vertices and edges. Say some these points are the vertices, say v1, v2, v3, v4. Sometimes these are called the nodes as well. And edges are nothing but lines which connect the two vertices. Say for example, say this is E1, say this is E2, this is E3, and E4. So I can see that there's an edge. This edge connects V1 and V2. So it's basically it is an unordered collection uh, of vertices. So for example, even if I had written say V1 and V2, or I could have written V2 or V1, the order here doesn't matter. So I mean these are equivalent notations. It's just a notation though. So edge is an unordered pair of vertices. I mean it connects the two vertices with a straight line. So let us look at a few topics which we will cover in this video. Is the first is the self loops. So self loops are nothing but edges which start from one vertex and end at the same vertex. So for example, we are looking at the vertex V2. There's an edge which starts at V2 and it again ends back at V2. So I'll name this edge as say E5. So as a notation, I'll write E5 starts at V2 and ends at V2. Or I can write in this fashion as well. Okay, so this is self loops. What about the second thing we will study is the parallel edges. So parallel edges are nothing but edges which the two edges same end at the same vertices. So for example, E1 has two vertices, say V1 and V2, and there's another edge, say E6. Now E6 and E1 have the same pair of vertices. So we say that say these two are the parallel edges. Sometimes we call them as multiple edges as well. Okay, so as such, this is a graph and it has some vertices and some edges. So now let us look at a new definition, which is simple graphs. So simple graphs are graphs which, so I'll put down the definition. So in a simple graph, first of all, there should be no self loops. And the second thing we should ensure is that there should be no parallel edges. So I spelled it. Okay. So, for example, the graph this graph which we are looking at, say the graph G, we can see here that there are self loops here, which is this loop E5, and uh, and we have the parallel edges E1 and E6. So, of course, this graph is not a simple graph. So, let us write down the vertex set of this graph and the edge set of this graph. So for example, the vertex set is the set of all vertices, say V1, V2, V3, V4. And the edge set, I'll name it as capital E. And edge set has how many vertices, how many edges? Say, I think 6 edges. So E1, E2, E3, E4, E5, E6. Now this graph defined by this vertex set and the edge set is of course not a simple graph. So if I had to make it a simple graph, either of course I'll have to first of all delete all the self loops. So for example, if I delete this self loop E5, so this is one criteria I have met, that there should be no self loops. And either if I delete E1 or either I delete E6, then it becomes a simple graph. So for example, if I delete E6, so yeah. So now if I when I delete the both of the self loops and the parallel edges, it becomes a simple graph. Okay, so let us look at what are null graphs. So null graphs are the graphs in which sorry, I'll spell this null graphs. I'll put down the definition. So null graphs have the vertex set and the edge set as empty. So the vertex set of the graph is an empty set, and the edge set of the graph is also an empty set. Okay, a natural thing to say is that if the vertex set is empty, of course the edge set also has to be empty, because edges, the end term points of the edges are the vertices. So if there are no vertices, there can be no edges. So for example, even if we say that this condition, the vertex set is an empty set, it automatically implies that the edge set is also empty. But the converse may not be true. But yeah, I mean, we are far from the definition of null graph. The definition is just that the the vertex set is empty and the edge set is empty. So as such, there's nothing drawn on the paper. I mean, there is no vertices and no edges. Okay, let us look at the last definition, which is adjacent vertices. So adjacent vertices are the vertices which are connected by an edge. So for example, this graph I drew earlier, say this was the graph, and this is E5 and this is E6, and let us say that this is some another edge, say V5. Now another vertex. So these are the vertices. Okay. So adjacent vertices are the vertices which are connected by at least one edge. So for example, E1 connects V1 and V2. So V1 and V2 are adjacent. Uh, V1 and V3 are adjacent by, and hence because there's an edge E2 which connects both of them. Okay. Are V2 and V4 adjacent? No, because there is no edge which directly connects from V2 to V4. So, if there was, say, some edge which connected V2 and V4, I would have said that V4 and V2 are adjacent. So, here they are not. So, yeah, so for example, V5 is V5 an adjacent edge to say V1 or V2 or V3 or V4? It's of course not, because there is no edge connecting V1 and V5, V1 and V2 and V5, and so on and so forth. So we say that the vertex V5 is an isolated vertex, and an isolated vertex is adjacent to no other vertex. Yeah, so that's it. That's all with the 5 definitions. Uh, yeah, that's all you do it in this way.